welcome to something new I wanted to try out. So as a brief introduction, I quite like talking about current things in the field of astronomy, or things that are used or cared about by astronomers. However, I haven't managed to do that a lot, because the format of my videos doesn't really suit it. Individual stories are too short, and the heavy editing a lot of my work has doesn't really fit. Stories disappear long before I think to talk about them. So, for example, I ended up talking about Hayabusa long after it got into space, and discussed an experiment about owls on zip lines weeks after the paper was out. So this is an attempted fix, a way of getting me to do interesting things. A calmer background, and to cover multiple topics in each video to take apart the shortness problem. Welcome to a week in astronomy. Not necessarily what's big or what made the headlines, but what stood out to this idiot behind the microphone. So first up, an interesting black hole, which I think was one of the big astronomical news stories of the week. An article by Todd Thompson and co-authors in the journal Science has came up with something interesting. So the usual way to find black holes is through emission in, say, X-rays. Material emits X-rays as it falls into a black hole and heats it up. However, this method relies on a black hole to be accreting enough material to make those X-rays noticeable. What about black holes which accrete little to no material? Clearly this is a form of bias in our data of black holes, which it would be good to reduce or limit. So we need to work out ways of finding black holes if the X-ray and gamma ray surveys aren't showing them. And the method these authors use is quite interesting. It involves binary systems. You have two objects in orbit around another, and they use what's known as the apogee experiment, which is a long and stupid acronym, which I'll link their site in the description for. And they know that data from that can be probed to find stars with a binary companion. They use a combination of radial velocity data, the star's velocity around the Milky Way, and what's called photometric variability, which has to do with variations in the amount of light seen from the star. And they found a promising candidate, a giant star which had a binary companion that we couldn't see. And then they can use their knowledge of the orbit of the star to start to constrain the details on the star, and of course, by our knowledge of mechanics, constrain the details of this unseen companion. And the final sentence of their abstract states the conclusion on the companion. After telling us the mass constraint, they say, indicating that it is a non-interacting low-mass black hole or an unexpectedly massive neutron star. So, fair likelihood that we've found a low-mass black hole in a way not done before. It would be the lowest mass black hole we've found so far. It would probably have a mass in what is referred to as the neutron star black hole mass gap, a range of possible masses where we find neither neutron stars or black holes. It's quite interesting. The idea of a mass gap has a few postulated explanations, and if we're to find more low-mass black hole objects using similar methods to this, we could start working out what caused it. Maybe the mass gap is due to bias in our detection methods. However, it could be that there is a mass gap, but there's a few rare and unusual circumstances that put some black holes in that space. And even if it isn't, even if it is just an unusually massive neutron star, an unusually massive neutron star is also really interesting and will change our viewing of the science of how neutron stars work. The other thing I wanted to talk about is something that came out in early October. I only found out about it this week though, so I say it counts. It's an editorial for Nature Astronomy, which points out something that I think anyone who talks about extrasolar planets has realised for some time. I'll link to the article in the description, but the brunt of it is that the terms we use to describe these planets conjure up images that are quite far from the truth. The editorial points out the problem with the fact that the term used to describe a large number of the planets more massive than Earth is super-Earths, a term which roughly means a big rocky planet if you're talking to astronomers, as the author points out. But the term Earth is loaded with meaning, and should an article also include the phrase habitable zone, the public immediately thinks that we are talking about Earth 2.0, a rocky planet with surface water and an atmosphere and perhaps a more striking sunset than ours. And who can blame them? This is true, and it causes a few problems, with the article ending by saying that we should be more careful with our wording. Imagine if you quite reasonably read a news-based article on some scientific research that says that scientists have found a super-Earth in the habitable zone. Especially if the author of the article is interested in hyping it up and the report includes speculations on aliens and beautiful artists' impressions of strange landscapes, you get slightly excited. Now let it be revealed that actually the planet probably has a surface temperature that would melt you, pressures that would crush you, and it might constantly be raining some horrible chemical mix which would dissolve your skin. Let that be revealed. And what would you be thinking about that? Moreover, if you thought the astronomers believed the planet was habitable, which isn't too unreasonable assumption, what would you be thinking of them? Wishful thinkers? Daft idiots looking to make a good story? And what would you think when the next lot of astronomers started pushing for money to try and find more of these Earth-like planets? The way the article finishes is by arguing that we don't take anything away from the amazingness of discoveries by being cautious with our language, with the final call of let us all be more vigilant. So my extra to this, I would actually be a lot harsher, although that's probably why I'm an idiot on the internet and not writing in Nature. So this would be my warning. We have to be incredibly careful. We have a wealth of experience on the reporting of public health and dietary advice, to give just one example, and we know the effect of over-enthusiastic reporting on public opinion and public actions. I reckon quite a few people have heard the old argument that since scientists keep changing their minds about what's good for you, keep smoking, keep eating horrendously fatty foods. Why not? Scientists will change their mind next week and it'll probably be good for you. No, if we want scientists' views on subjects where space research meets, say, political ideology and human need, to be heard without being instantly scoffed into derision. Because there are places like that. Predicting and preparing for space weather, monitoring the climate from space, problems caused by man-made space debris. There are a lot of areas where astronomy meets important political issues. We put ourselves in a very bad position if we made it so that quite often people would dismiss astronomers far more easily than perhaps their expertise or their knowledge on the subject would be worth. So this is something I think we should really care more about. Again, I'll link to the article of it in the description. So there you go. The first week of hopefully something different, and hopefully it's enjoyable. Goodbye.